So now that we've done some work with inequalities, we're going to move into solving absolute value equations. Today we're going to solve simple absolute value equations, we're going to solve multi-step absolute value equations, and we're also going to use our knowledge of absolute value to determine if an equation has no solutions. So remember that absolute value is a number's distance from 0 on the number line. Since absolute value measures distance, this means that it's always positive, because you can't have a negative distance. So let's just do some quick review of absolute value. What's the absolute value of 5? 5. 5 is 5 spaces away from 0 on a number line. What about negative 5? Negative 5 also has an absolute value of 5, because negative 5 is also 5 spaces away from 0 on a number line. So even though positive 5 and negative 5 are on opposite sides of 0, they both have the same absolute value. What about the absolute value of 3? That would be 3, and the absolute value of negative 3 would be 3 as well. So what if we had an unknown number and took its absolute value and knew that its absolute value was 7? What are the possible values that x could be? This means that x could be either 7 or negative 7, because both 7 and negative 7 have a distance of 7, or an absolute value of 7, from 0. What if we knew that x plus 1, or the absolute value of x plus 1, equaled 4? What's one value of x that we can think of that would make this statement true? Well, if I'm looking at this, and if x were 3, that would mean that 3 plus 1 is 4, and the absolute value of 4 is 4. So my first x value that I can think of would be 3. X could equal 3. But if we could get what's inside the absolute value bars, which is x plus 1, if we could get it to equal negative 4, then it would also have an absolute value of 4. And so our next job is to figure out how could we get what's inside the absolute value bars to equal negative 4. It was a little bit easier when we were trying to get it to equal positive 4. 3 plus 1 was just 4. If you can't do this one in your head, what we can do is we can set up an equation to try to get x plus 1 to equal negative 4. And then I could solve that equation by getting x by itself by subtracting 1 from both sides, which means that x could also equal negative 5. Now this might seem a little strange because back here we were getting the same number but just the opposite. But remember, we did 3 plus 1, which was 4, and the absolute value of 4 was 4. Now if I were to do negative 5 plus 1 would be negative 4, but the absolute value of negative 4 is also 4. So this type of an absolute value equation is going to have two solutions, and they appear to be pretty different. Let's practice solving these a little bit more. So once we have our absolute value bars equaling a number, what we can do is we can set up two equations. Equation 1 would be figuring out the value of x. That would make it equal the positive number. And our second equation would be figuring out what would make it equal the negative number. Because if I can get what's inside my absolute value bars, x minus 3, if I can get that to equal 8, then it will have an absolute value of 8. But if I could get x minus 3 to equal negative 8, it will also have an absolute value of 8. And so then we're going to solve these two equations the way we would solve any equation, by isolating x. So I'm going to add 3 to both sides of my first one. So my first solution is that x could equal 11. And then on the second one, I'm also going to add 3 to both sides. But this time, negative 8 plus 3 is negative 5. So the two possible answers or solutions are going to be that x could equal 11 or x could equal negative 5. And we could check it by plugging in x. 11 minus 3 is 8, and the absolute value of 8 is 8. And negative 5 minus 3 would be negative 8, and the absolute value of negative 8 is 8. Try examples 2 and 3 by setting up two separate equations. Pause the video, press play when you're ready to check your answers. So on example 2, my two equations that I'm going to set up are x plus 4 equaling 3 and x plus 4 equaling negative 3. If I can get what's inside the parentheses to either equal positive 3 or negative 3, it will have the correct absolute value. In both cases, I'm going to subtract 4 from both sides, and so my two solutions are that x could either equal negative 1 or x could equal negative 7. Let's prove it. Negative 1 plus 4 is positive 3, and positive 3 has an absolute value of 3. Negative 7 plus 4 is negative 3, and negative 3 also has an absolute value of 3. On example 3, my two equations that I set up are x minus 7 equals 9 and x minus 7 equals negative 9. If I can get what's inside my absolute value bars to either equal 9 or negative 9, it will have the correct absolute value. In both cases, I'm going to add 7 to both sides. So one of my solutions is x equals 16, and my other solution is x equals negative 2. We can check it. 16 minus 7 is 9, and that has the correct absolute value. Negative 2 minus 7 would be negative 9, and that also has the correct absolute value. Now we're going to get into some more complicated examples. And so if you just take a quick preview at example 8, you can see there's also a number out in front of my absolute value bars, and then there's also something being subtracted. So in order to do this, what we're actually going to do is we're going to isolate we're going to call it the argument. And the argument is the name of the thing that lives inside the absolute value bars. So for example, on examples 2 and 3, when I was highlighting x plus 4 and x minus 7, I was actually highlighting the argument. So we want to isolate the absolute value bars first. And so we would do that the same way we would do any type of equation solving. So if my goal is to get 2x minus 7 isolated, I need to get rid of both the 3 that's multiplying it and the minus 5 that's subtracting it. And I'm going to go in reverse PEMDAS order. So first I would add 5 to both sides, rewrite my equation. So I would have 3 times the absolute value of 2x minus 7 equals 9. I'm still trying to isolate my argument of 2x minus 7. And so then to do that, my next step would be to divide by 3 on both sides, which means that the absolute value of 2x minus 7 would equal 3. Now that my absolute value, my argument, is isolated, I can set up my two equations. Because remember, if I can get 2x minus 7 to either equal a positive 3 or a negative 3, it will have an absolute value of 3. So my first equation that I would set up is 2x minus 7 equals 3, and then my second equation that I would set up is 2x minus 7 equals negative 3. In both cases, I'm going to add 7 to both sides first, since I'm going to use reverse PEMDAS. So here I would get 2x equals 10, and here I would get 2x equals 4. Then my last step on both would be to divide by 2. And so my first solution would be x equals 5, and my second solution would be x equals 2. And so again, if I go back here, I could check my solutions. 2 times 5 is 10. 10 minus 7 is 3. 3 has an absolute value of 3. 3 times 3 is 9. 9 minus 5 is 4. Then I could check it with 2. 2 times 2 is 4. 4 minus 7 is negative 3. The absolute value of negative 3 is 3. Times 3 is 9. Minus 5 is 4. So I've just proven that both of my solutions are correct. Let's try one more together. Let's try example 9. So again, my first step is to get this isolated, which means I need to get rid of the 2 and the 4. I'm first going to get rid of the 4 because reverse PEMDAS by subtracting it from both sides. 2 times the absolute value of x will equal 14. Divide both sides by 2. Absolute value of x can equal 7. And at this point, I've just got my x by itself already, so I could set up my two equations. One equation is x equals 7, and my second equation is x equals negative 7. But in both cases, I don't really have anything to solve for because x is already isolated. And looking at this, we can kind of go back to our knowledge of absolute value, that x could be 7 and have an absolute value of 7, or x could be negative 7 and have an absolute value of 7. So you're going to pause the video, try examples 10, 11, and 12. Make sure you begin by isolating your argument and then setting up two equations. Press play when you're ready to check your answers. So on example 10, I first added 5 to both sides, then divided by 4, and now my argument is isolated, x plus 9. So if I can get the absolute value of x plus 9 to equal 6, that means that either x plus 9 would need to equal 6, or x plus 9 would need to equal negative 6. In both equations, I would subtract 9 from both sides, and my two solutions are negative 9 and negative 15. On example 11, to isolate my argument of 4x plus 2, I'm first going to add 7 and then divide by 3, which told me that the absolute value of 4x plus 2 would need to equal 6. So if I can get 4x plus 2 to equal 6, or if I can get 4x plus 2 to equal negative 6, those values would make that have an absolute value of 6. In both equations, you're first going to subtract 2 from both sides, then divide by 4, and so my two solutions are x equals 1 and x equals negative 2. On example 12, I first subtracted 6 from both sides, which told me that the absolute value of 3x plus 5 would need to equal negative 8. And I started setting up my equation, and then I realized, wait a minute, if I'm going to take the absolute value of something, it can't equal a negative number. That's not possible. So that means that this absolute value equation has no solution.